a lot of time proving triangles congruent. Today I'm going to show you how to prove triangles similar. First thing right off the bat, we all remember our congruent sign, right? Anybody know the sign for similar? No? Take away the equals. That's your sign for similar. Right? They call it a tilde. I don't know if anybody knows that. They call it a tilde. So there's our sign for similar. All right, first thing I want to show you, what happens when two triangles are similar? Because we know when two triangles are congruent, the sides are congruent, and so are the angles. So if I tell you these two triangles are similar, so we'll just put the tilde there. I'm going to call this one ABC, and I'll get creative and call this one DEF. So what happens when two triangles are similar? First thing, corresponding angles still equal. Corresponding angles are still equal. So I'm going to say angle A is congruent to angle D with my arc marks. I'll also say B and E. And I know I don't have to, but I'll do triple for C and F. Okay, so if two triangles are similar, the corresponding angles are still congruent. Here's where things change. The corresponding sides are not congruent. Instead, this is something we talked about yesterday. The corresponding sides are in the same ratio. Here's what I mean. Let me put some numbers down for you. Let's say AB is 5. I'm going to say DE is 15. AC is 10. DF is 30. You see what I mean when the corresponding sides, 5 over 15, does everybody agree, is the same ratio as 10 over 30? All right, let's see if you really pick this up. Let's say BC is 8. How long would EF be then? The triangle that's similar to it would not be 8, but it would be 24. Okay, so the sides that match up, the corresponding sides are in the same ratio. All right, all the sides are in the same ratio. So that's what happens when two triangles are similar. Just like congruent, we're going to write similarity statements, and you guys are going to get frustrated pretty quick, and I'll show you why. So call the first triangle any way you want to call it, just like we did. Here's why you're going to get frustrated. What are you brainwashed right now to write next? Congruent, congruent, congruent. Get out of it mindset. It's got to be similar now. All right, got to be similar. That's an awful tilde. It's got to be similar. And the rule still applies. The sides and angles still have to match up in the second one. All right, so just like we did for congruent triangles, the sides and angles in the second triangle do have to match up. So we call this triangle DEF. Just watch out. All right, make sure you write the similar symbol, not the congruent one. And last thing, vocabulary term, scale factor, similarity ratio. That is the ratio the sides are in. All right, the ratio the corresponding sides are in. So for us, pick two sides that match up. I could go 10 and 30. I could go 5 and 15 or 8 and 24. Doesn't matter. I'll go 10 and 30. That could be a good scale factor or similarity ratio. Hey, you want to reduce it? Sure, reduce it. 1/3. Okay, I don't care if it's reduced or not. The only thing to watch out for, most problems will tell you what order to write it in. Because 1/3 is a different ratio than 3/1. All right, so most will say find the similarity ratio for triangle ABC to DEF. So ABC would come first. All right, so most of them hopefully will do that. All right, so that's what happens when triangles are similar. Questions? All right, when we talked about congruent, how many methods did we have for triangles to be congruent? We've spent years on this. How many methods to prove triangles congruent? Oh my God. How many methods?
5.
5, thank you. There's 5. I don't need to know what they are. Just can we all agree there's 5? Well, how many ways are there to prove triangles similar? 3.5. All right. You can't have a half. Relax. I'll show you what I mean at the end. All right. But there's 3.5 methods to show triangles similar. Let me show you the main method first. And that is, we finally get to write it down. Finally. Angle, angle. All right. I know all of you were at the beginning when I showed you how to prove triangles congruent. Some of you would always write A, and I just want to put you in a headlock. That's never a way to prove triangles congruent, but it is a way to prove triangles similar now. Yes. So here's reason number one, angle, angle. Now, why didn't I write the third A in angle, angle? Why, John? It's overkill. You know the third pair already if the first two are. Also, I don't care if you write the tilde or not. That doesn't bother me. All right, you can write AA without it. But yes, if you find two pairs of angles congruent, the triangles are similar. Okay, triangles are similar if you find two pairs of angles that are congruent. So you guys are going to love those proofs when we start tomorrow. That's all you need. Two pairs of angles, I'm done. Triangles are similar. Speaking of a quick proof, let's do a quick two-column proof why these two triangles are similar to each other. So real quick, I know you missed them. I just want you to get back into the groove for tomorrow. What am I giving you here? I did give you something. What about H and S? You already know they are congruent. So H congruent to S. That's what I'm giving to you. But I need to prove these triangles similar. So that means I need another pair. I have one pair of angles. I need another pair now. And real quickly, where's that other pair? My vertical angles. Please don't put angle O equal to angle O. Angle UOH is congruent to angle SOE. Vertical angles congruent. And that's it. These proofs are nice. Angle, angle, that's it. Once I have that, now I can say the triangles are similar. So triangle UOH, I'll call it UOH. How many of you did it? You did it. How many put congruent? Yeah, got them. Got a couple. Yeah. I don't know why I get so much delight in your mistakes, but hey, that's how I roll. When your heart's covered in ice, that's what happens. UOH, and then I got to go EOS if I want to match them up. Angle, angle. Finally get to write it. Again, you want to put the tilde there, fine. If not, that's fine too. Angle, angle, reason number one, to prove triangles similar. Questions, comments, concerns? Reason two. Ho-ho! Looks pretty familiar, doesn't it? That's one of our ways to prove triangles congruent. Whoa. It's a little different though. Side, angle, side, similar. Side, angle, side. Yes, the angle in between still needs to be congruent, but the sides in the same ratio. Okay, the sides need to be in the same ratio. So here's what I mean. Look at my diagram I have up above. Everybody can see the angle in between are congruent, but are the sides in the same ratio? You need to test that. Are those sides in the same ratio? And here's how I decide. So I take one side from one of the triangles. I'll take 10. And now I figure out what side that matches up with on the other triangle. So smallest side usually matches up with the smallest side. So 10 would match up with, correspond with 15. Are those two in the same ratio as the other two I'm given, which are 12 and 18? Are those two the same ratio or not? Now, easy way to tell, grab your darn numworks, do 10 over 15 and 12 over 18 and see if you get the same fraction. All right, and I believe you will, right? You'll get what, 2/3 here and 2/3 here. So they are similar by side, angle, side. Do we see what I mean by the sides are in the same ratio? You're going to have to test that. Okay, it's just because I see side, angle, side doesn't mean they're similar. You have to test if those sides are in the same ratio. All right, questions there? All right, what about this one? Are these triangles similar or not? Well, it can't be angle, angle, right? Because I only have one pair of the right angles. But it does look like it could be side angle side. Could be. I need to see if those sides are actually in the same ratio. All right, what's the 8 match up with? What's the 8 correspond with? The 6 in the other. So does 8 over 6, is that in the same ratio as 4 over 3? Are those the same ratio? Yeah, they are. 8 over 6 reduces down to 4 over 3. And I should mention this because you guys are in honors. Do you know the other way to see if they're in the same ratio? Other than just reducing them or plugging them in your calculator? Jen, what's up? Darn right. If you cross multiply, you should get the same thing. Good. 24, 24. All right, so this is a yes. Write a similarity statement. Triangle BAC. Let's go. Similar to triangle EDF. And here's the most important part. And all joking aside, by side angle side, and I need the tilde here. Why? Why am I going to need for you to put the tilde on this one versus angle angle? Why do I need it there? Go ahead, Ziv. Yeah, now you're separating it from the method to prove triangles congruent, which is just side angle side without it. So I do need the tilde there. Questions, comments before method 3? So we had what? Angle, angle, side, tilde. And now the third method should look pretty familiar as well. Side, side, side. Now all 3 pairs of sides need to be in the same ratio. All 3 pairs of sides. And the first question I always get from all the students is, how do you know how to match them up? How do you know? Like the 5 in this triangle. What is the 5 going to correspond with in the other one? I'll make it easy on you. The smallest side always corresponds to the smallest side. The largest side of one triangle always corresponds to the largest side of another. So the 5 would correspond with 10. Is that in the same ratio as, keep going, 8 over 16? Hey, and even if these 2 work, that's not side, side, side. There's a third S you need to test. So make sure if the first 2 work, that doesn't mean anything. All 3 have to be in the same ratio. So 13 over 26, I believe those are all good. So this is an example of side, side, side similarity. We good? I almost said bless you. Sorry. You good, Joel?
Yeah.
Okay. Hey, I know you get nervous in here. It's all right. All right. I mentioned 3.5 steps. Well, here's the half. I call it the desperation method. And that is, if I ever give you a proof and I ask to prove the triangles similar, but you look at it and you're like, wait a second, I can prove them congruent. Congruent triangles are similar. Okay, congruent triangles are similar. So go ahead, prove them congruent. And then right after you prove them congruent, you can say they're similar. Very rare, very, very rare. That's why I only put it as a half a reason. It's a year. I don't know if any time you're going to use that, but it's there. It's there. Congruent triangles are similar. All right, questions. Now we're going to play a little game. Are the triangles similar or not? You have 3.5 reasons. Let's look at 2 triangles there in number 1. Are they similar? What do we think? Are they? Yeah, I see a lot of heads. Yeah, yes, they are. If so, write a statement. Triangle AXB. You good, Heather? Did you do it? Good. Yeah, there you go. Progress. Triangle. You did it, didn't you? You put congruent down.
No.
Matt, yeah, okay, yep. All right.
It's too far over. I had to put it under.
All right, yep. Triangle AXB similar to, let's see, A is congruent to R, so that's got to start with RXQ. All right, what method you got for me then? What's the method? Angle, where's the, we didn't talk about it, but where's the second pair? Yep, the verts. There you go. Done. All right, how about number 2? It could possibly be 2 methods, right? Side angle side or side side side. Okay? So choose which one. We still got to test sides to see if sides are in the same ratio or not. All right. So anybody want to give me anybody spout off a side from one triangle? Give me a length of one side from one of these triangles. 12. Great. All right. What's the 12 correspond with in the bigger triangle? I thought we were talking about the 12 of the smaller. Okay. What's the 12 correspond with in the bigger one?
16.
All right. Does 12 over 16, is that the same ratio as 9 over, let's see, the 9 would correspond with the 12 in the bigger one? Are those in the same ratio? 12 over 16, 9 over 12? And again, if you're unsure, go back to Gianna's method, which is cross multiply, or type it in NumWorks, both fractions, and it should give you the same reduced answer. And yes, it is. They are equal. So for me, I'm going to stop here and do side angle side. If you wanted to, though, right, we could say, is those two the same ratio as 15 over 20, and we could do side, side, side. Okay, either one works. So this is a yes. Triangle XPM, similar to triangle AWL, if I go that way. By side angle side, put the tilde there, or depending on how you did your ratios, side, side, side with the tilde. Any questions here yet? Okay, number 3. What's the only possible method it could be? Could be side angle side, right? Because I got the verts here. Could be, doesn't mean it is. I need to test if those sides are in the same ratio. And we're going to come up short, I think, here. So does 3 over 4 in the same ratio as 4 over 8? And we could see right away that's a big no, right? 16, 24. So these are not similar. My biggest thing, you still have to test if the sides are in the same ratio. All right, anything on testing? That's no issue with me, and I don't think that'll be an issue with you. Here's where the issue is going to be in the second half of the notes. You know the triangles are similar. Now you have to create your own ratio and solve for the missing side. All right, this is where I think might have a little trouble, but we'll see. All right. So we see these two triangles are similar by angle, angle. Which proportion can I use to solve for x? Because only one of them is correct. The other 3 are incorrect proportions. Here's what I want to do with you guys. I just don't want to pick the right answer and go. I want to go through each one, tell me why it's wrong if it is, and if it's right, obviously we'll circle it and go, but I'm more important with why it's wrong. All right, everyone ready? Look at number 1. X over 24. Okay, I'm fine with it. It doesn't really matter how you start it. It's how you finish. So x over 24. But now, take a look at the diagram. What should x match up with in the other triangle? It should match up with, put the angles on top of each other. It should match up with the 15, but the way the proportion's written, it matches up with 9. That's a problem. It should be a 15 there. So that's why number 1's wrong. They matched up the sides wrong. All good there. All right, let's look at 2. Now notice how they started. They matched them up right away. 24 and 9. Do they match up with? They match up, right? But here's the problem. They put 15 first. Well, if you put 24 first here, you should put another side from that triangle here as well. And notice how they put 15, which does not belong to the triangle that 24 has. So we see why this one's incorrect. 24 did match up with 9, but right here should have been a side from the triangle that had 24 in it. So it should have been flipped. How's 3 look? So 32 and x, they took two sides from the same triangle. Does 32 match up with 12? Yeah. Does x match up with 15? Yep. So that's going to be our good one. Why is 4 bad? And why is 4 incorrect? What went wrong with 4? 32 does match up with 12, but what's wrong with the 15? That should be a side from the 32 triangle. Okay, that should be a side from the 32. Questions? All right, let's see if we can do this on our own now. Can we make these proportions on our own? Whew. So these two triangles are similar. So their sides are in the same ratio. We just have to build that ratio and proportion now. And what are we looking for? ML? All right, here we go. This will be your personal preference. You either start with two sides from the same triangle or you start with two corresponding sides. Me personally, I always start with two corresponding sides. Some of you may start, x over 7, and then match them up. That's you. Me, I match them up right away. That's how I roll. If you don't like the way I roll, then write your own proportion. That's fine. So I'm going to say, what does x match up with in my bigger triangle? Well, x is ML. And just like congruent triangles, they write it in the specific order. So if I'm concerned with, and you guys are going ahead, but that's fine. If I'm concerned with what sides match up with ML, I'm going to look at the statement. There's ML, the first two spots. What's in the first two spots over here? QR. So I know ML and QR match up, so I got to put 30 underneath because they match up. All right, I started off with the triangle that had side X, so I need another triangle, another side from that triangle, which would be 7. And now I got to figure out what 7 matches up with in the bigger one. So I look again, LN, first and third. Over here, first and third, QS. So QS, 21. Everyone look at my proportion, please. That is not the only way to solve this problem. If you are looking at a different proportion on your paper, you might be correct. Are you cross-multiplying X and 21? And are you cross-multiplying 30 and 7? Because if the answer is yes, you also have a correct proportion. All right, it does not have to match mine. There are different ways to write this proportion. As long as we are always cross-multiplying the same things, keep going. Don't change it. Now, unlike yesterday, this is an easy one to cross-multiply. All right. Sooner or later, though, you're probably going to have to factor to solve it. But this one's just 21x equals 210. Divide both sides by 21. X equals 10. What's up, Aiden? Go ahead.
If you know the triangles are similar and you could find the ratio of one of the sides, couldn't you just find the ratio?
Yeah. So if you see 7, I multiply by 3, divide by 3 to go backwards. Yep. But sometimes that's not going to be easy to see. It might be multiply by 2.4. And that's not, like this is just multiply by 3. So if that's the case, yeah. Yeah, absolutely. Any other questions, comments? Just like this one's an easy one to see too. But so sides of a triangle, 7, 4, and 9. And I got a similar triangle that looks like to be a little bigger. And the longest side there is 36. What's the shortest side of this triangle? Right, shortest side. So how are you going to build your proportion? You're going to start with two sides from one triangle or two corresponding sides? I always start with two corresponding sides, so X and 4. So if you start with two corresponding sides, make sure your first side here comes from the same triangle. So for me, 36 corresponds with 9. And again, this is something that Aiden just said, hey, I'm multiplying by 4. So I can get to it pretty easily. Sometimes, though, you're not going to notice what the pattern is. It's at 144. Before we move on, there's one big thing I have not talked about. And I didn't talk about it because it hasn't come up. And that's not part of your note here. Here you go. You guys are going to start doing some work on your assignment where you have a triangle within a triangle, and they'll be similar. Okay, so I'm just going to put some random values up here. X, 2, 5, 8. All right, and these two triangles, everyone sees the two I'm talking about, the smaller one inside the bigger one, are similar. When, I get fired up about this, when you set up your proportion, full sides only are allowed in your proportion. Full sides only of each triangle, meaning 2 and 8 should not appear up here. Full sides only. So if I had a proportion to do here, ready? 5 would match up with what side in the bigger triangle? Not 8. That's not a side. What's the actual side length? 13. So see that? The 5 matches up with the 13, and the X, what would the X match up with? Not 2, that's not a full side. How do you, whoa boy. How long is this side right here? If you say 2X. 2 plus X, X plus 2. Yep. Okay? Full sides only in the proportions, not partial sides. Full sides of each triangle. Good? All right, get rolling. Go ahead.